taking unorganized data and putting it into usable form so it actually means something to you. And one of the ways we do that are with stem and leaf plots. Here are apparently the temperatures in degrees Fahrenheit for April in New Orleans, Louisiana. Create a stem and leaf plot. And they give it to you in the steps that you really probably should follow. You could kind of skip this step and do the stem and leaf plot kind of all at one time. This would be a more organized way to do it, probably keep you a little straighter, but you could right away draw your stem and your leaf right off the bat and do it like this kind of. And remember, the leaf is one single digit always. The leaf is always a single digit. The stem could be more than one digit. In other words, if I had numbers that were in the hundreds, like 125, 136, 118, okay, and you're doing a stem and leaf plot of those, okay, whatever you look, the last digit is what's going to go over here in the leaf part, and whatever's to the left of those, okay, this is always going to be the leaf part, the leaf. Whatever's in front of it is always going to be the stem part. So if you were organizing these three in a stem and leaf plot, okay, the stem would have to be the 11, the 12, and the 13, and it would be 11, 12, 13, and the leaves would be an 8, make 118. You have the 11. You know, this is really 11 tens plus that 8. The 12 is 5, and the 13 would be 6. That would be the stem leaf. Here they were just in the tens, so it worked out just being a single digit in both the stem and the leaf.
That's it.
That is it. But when you organize it, and we'll do an example here in a minute just so you can see it there. When you organize it, the reason you organize it is because it can make all those, make finding all those modes of whatever central tendency thing, when you try to find the mode, the median, the mean, which we're not going to do because I'm not going to do average of all of that, and the range. If you're looking at a stem and leaf plot, you should be able to easily and quickly find these three things right here. In other words, what number appears the most if you're looking at this stem and leaf plot? Well, you'd have to look and see which one of these things, you know, what digit repeats the most. There's 3 8s, 3 0s, 3 1s, 3 3s. This actually has 4 modes. What would they be? 78, because you have to put the stem with it. You'd have 78, you'd have 80, you'd have 81, and you'd have 83. Those are your 3 modes. How would you use that to find the middle number? Somebody else entertain notions out there in the 8th grade thinking world. Usually when we used to do this, we'd write all the numbers from least to greatest and figure that out. But they already are. If you go like this across, that's from least to greatest. So you'd have to figure out how many numbers there are total, which would be how many entries. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. There are 30 numbers represented on this thing here. What is the middle of 30?
8.
Well, not really. Okay. It's the number that falls between 15 and 16. If it's an odd number, there's an odd number in the middle, but if it's an even number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, okay? This separates it from that and that. So your 2 numbers you have to look at are 78 and 80. And if it's an even number, you have to take an average of those, which hopefully you can do without a whole lot of work. What falls right in the middle of 78 and 80? Yeah, the median would have to be 79.
Wait, what if it doesn't, like, what if it's like 31? Say,
If it would have been 31, then whatever number was next to this 8, that is exactly in the middle already because there's 15 numbers on this side of it and 15 numbers on the other side of it. You hope for an odd number of digits because then there's an exact number that falls right exactly in the middle. If it's an even number, you have to find the 2 in the middle and take the average of the 2. And then how about this one, the range? Well, the range is the difference between the smallest, which is 53, and the biggest, which is 87. The range in this case would be 34. I'm not gonna make you do the mean of it, 'cause not. We also did quartiles, didn't we? We did quartiles. Did we do quartiles? Let's do that. Lower quartile, Q1, Q2, Q3.
No.
Jim?
No.
Oh,
Somebody had to
don't
do it.
remember.
It was probably Nick.
There's
We don't do
probably.
it.
Now, with that being said, let's see if we can make heads or tails of this. With this right here, this actually is the practice in your book, so, but you don't have to look at your book, let's just take a look at it here. So let's say you've got these, data points and you wanna make a stem and leaf plot. Okay, what is that going to look like? So here's my stem, and here's my leaf. Again, knowing the leaves are the last digits, what digits am I gonna have for my stem? What digits fall in front of, how many different digits do you see fall in front of, what is this? That's a 6, right? That's a 7, 6, 6, 5, 5, 4, 4, 5, 6, 6, 6. So in my stem, I'm going to have what? A 4, a 5, a 6, and a 7. Because all the numbers fall in the 40s, the 50s, the 60s, and the 70s. Correct? And then as you do this, like they said to number them, but I'm saying you can probably do it. It's a little more confusing kind of to do it this way, but it might save you a little time. 65, what would I do? I would put a 5 here in the 65. I left a space there because there's probably going to be some numbers. You need to put them in order. So if there's a 74, it needs to go there. 70, a 7 and a 0. You can't get any lower than that. 69, a 6 and a 9. 61, put one right there. 56, are you with me? 5 and a 6. 52, probably right there. 43. 42. 51. 60. 63. 82. You have to put doubles. If there's 3, you gotta put 2. 60. Whoa. Oh, did I put that 60 in there? I did, didn't I?
Ooh.
Was this 60 from there? Yes, it was. Was there 2 60s? Where's the other one? This one? Oh, so I do need to put another 0 in there. 0 and a 54. And a 50. So this would be the stem and leaf plot for that date there. If I asked you to find the median, you'd have to know how many numbers did we just do there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, yippee, because there is a number exactly in the middle of 15, and that is the 8th digit, because you got 7 on either side of it. So 1, 2, 3, 4, 5, 6, 7, 8. The median would be 56. The mode would be, it's bimodal because it has those 2 repeat and those 2 repeat, so 52 and 60. The range 17, 23, blah, 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 blah. Now, we do have to talk about letter B there. What is a there's one other thing. If you look on there, it talks about in practice, are you on 62? Somebody
Yeah,
flip this.
I'm 60. Oh.
Go to 62, because one other thing you have to talk about, they talk about relative frequency. Write this down in this same note here. Relative frequency. Relative frequency is just them asking what percent is the number of all the data. So if I asked you what is the relative frequency of 52? Okay, to find the relative frequency, you just take how many 52s there are. How many 52s were there? How many 52s did I have on my stem and leaf plot? 2. Over how many total? How many total data things did I have? I already said it was 15. You need then to make a percent out of that. 2/15 is what percent? And there's an 8th grade question. How would you change 2/15 to a percent? Christine? Yeah. How would you change 2/15 to a percent, Grace?
Don't you divide?
Yeah, you could. Divide 15 into 2 and see what your decimal is and then change that to a percent. You get 1. How many times does 15 go into that? What, 3 is 45? You keep getting 5s. It's 13 1/3%. That would be the relative frequency of 52. So if they ask you relative frequency, you just make a fraction of how many times it happens. And then the last thing is a histogram. Children. And I know we did histograms because I've done it with the 5th and 6th graders numerous times. Here will be your quick and exciting review of histogram. A histogram is nothing more than a stem and leaf plot turned on its side. You just rotate it basically. In other words, a histogram, when you do a histogram, it's like a bar graph that there's no spaces between. If I was doing a histogram of whatever this represents, okay, what does it represent? Okay, a histogram tells you the frequency or how many of something. And these bars here would tell you, let me do something small here. You'll see once I do it that it's not that hard. I'm going to split this into how many different, 1, 2, 3, 4 little rows. 1, 2, 3, 4. Okay, and then the frequency occurs once, occurs twice, occurs 3 times, 4 times, 5 times, 6 times. And here is the deal. This little bar here is the increments that are in the 40s. So you'd go from, this would be from 40 to 49. And if you look, how many digits appear in the 40s? No, just one. That stands for 45.
Oh, look at that.
So this is just, you just color in 1, the frequency of 1. There's 1 number in that range from 40 to 49. Then your next one would go from 50 to 59. I'm going to give you a second chance. How many things, how many numbers are from 50 to 59? 1, 2, 3, 4, 5, 6. So you got to go all the way up 1, 2, 3, 4, 5, 6 to here. Then you'd go from 60 to 69, which is how many? Alexa? 1, 2, 60, 63, 63, 64, 64, 68, 68, 2, 4, 6, 7, it looks like, is it? Am I right? Am I right or am I right?
You're right. Yeah.
It's the Papa Giorgio. And the last one, how many are in the 70s? Just 1. This is your histogram. Histograms just tell the frequency of a range of things. You would do a histogram if you were showing grades on a test. You know, the number of tests that were from 90 to 100, from 80 to 90, 70 to 80, and then how many people, how many people got those scores. For example, if I were doing a histogram on your test scores, heaven forbid, it would look a little like this. People that got, we'll do this, less than a 65, and then people that got from 70 to 80, or actually I should go 70 to 79. 80 to 89, and 90 to 99. And since nobody passed, or nobody got 100,
Yeah, I got a B plus.
a B plus,
Yeah, so did I. And then the one before that, I got an 8 today.
everybody did.
No.
Yeah.
And then your histogram would look like this. Let's make a nice color. Your histogram would look like this. Nobody didn't pass the test, so there's nothing there for that. A couple people, 1, 2, 3, 4, 2 people got between a 70 and a 79. 5, 6, 7 people got between an 80 and an 89. That would be this little bar here. And then the rest, which would be what? 7, 8, 9, 10 people. Well, they did take the test, so we'll go 9. 9 people.
Yeah.
And that is your histogram of that.
Did you take that test